Far out in the frozen darkness, a world named Orcus defies every expectation. This distant dwarf planet in the Kuiper Belt holds 25 profound secrets that challenge the very foundations of solar system science. By the end of this journey, you will see our cosmic neighborhood in a completely new light. We will investigate its strange mirrored orbit with Pluto and the tantalizing possibility of hidden oceans beneath its icy crust. What fundamental truth about our solar system's history is Orcus keeping from us? The first mystery begins with a cosmic dance partner for Pluto. Far across the solar system, the dwarf planet Orcus moves in a strange and perfect synchrony with its more famous twin. Their orbits are locked in a resonant duet, a gravitational harmony that sees Orcus completing 2 circuits around the Sun for every 3 that Pluto makes. This is not a chance meeting. It is a persistent clockwork relationship maintained across billions of miles of empty space. Think of 2 swings on a vast playground, pushed at different times, yet somehow always reaching their highest points together. This precise mirroring in both orbital period and inclination is a clue that cannot be ignored. Simple gravity alone struggles to explain such a perfect, long-distance arrangement. It points to something deeper, a hidden chapter from the solar system's violent youth. Perhaps both worlds were shepherded into these paths by the gravitational influence of a giant planet that has since migrated away. Or maybe they are remnants of a much larger family of objects whose interactions sculpted their current routes. This peculiar synchrony is our first hint that Orcus is not just another frozen rock, but a keeper of ancient secrets about the forces that built our cosmic neighborhood. This cosmic dance is not a solo performance. Orcus is accompanied by a partner of its own, a mysterious moon named Vanth. Together, they form a binary system that mirrors Pluto and its large moon Charon in a deeply puzzling way. The sheer size of Vanth relative to Orcus is the first piece of this puzzle. It is not a tiny speck orbiting a giant world, but a substantial companion, creating a system where the 2 bodies seem to whirl around a common point in space. This arrangement is incredibly rare in the outer solar system, and its similarity to the Pluto-Charon system cannot be a simple coincidence. So how did this peculiar pair come to be? Scientists are locked in a debate with 2 compelling yet conflicting theories. The first suggests a violent, ancient collision. A gigantic impact, much like the one thought to have created our own moon, could have shattered a young Orcus with the debris coalescing to form Vanth right beside it. This would explain their intimate orbital dance and similar compositions. The second theory proposes a more gentle capture. Perhaps Vanth was a free-flying Kuiper Belt object that strayed too close and was gravitationally snared by Orcus, a cosmic embrace that locked them together for eternity. Each theory, however, faces its own challenges. A giant impact seems almost too perfectly tailored to create such a balanced system so far from the Sun. Yet a capture event seems equally improbable, requiring a fantastically precise set of conditions to slow a passing object down just enough for it to be captured, rather than slingshot away or crashing directly in. The unique characteristics of the Orcus-Vanth system stand as a silent challenge to our understanding of how worlds form in the cold, dark reaches of space. What forgotten event in the deep past forged this enduring partnership? The enduring mystery of Orcus and Vanth is written in their orbital dance, but the secrets of Orcus itself are painted across its surface. Scattered across this distant world are brilliant, unexplained patches of light that gleam against a much darker landscape. These are not subtle shadings, but stark, reflective regions that shine like beacons in the void. What could possibly be so bright in the perpetual twilight of the outer solar system? The leading suspicion falls on water ice, fresher and cleaner than the surrounding terrain. Think of a field of old, dirty snow next to a patch that has just fallen, pristine and white. That is the kind of contrast we are seeing from billions of miles away. This immediately presents a profound puzzle. In the airless environment of space, surfaces are expected to darken over time, bombarded by relentless cosmic radiation and micrometeorite dust that creates a dark, sooty coating. For these bright patches to exist, something must be actively renewing the surface, scouring it clean or bringing fresh material up from below. This points directly to recent and potentially ongoing geological activity. One thrilling possibility is cryovolcanism. Instead of erupting with molten rock, a cryovolcano on Orcus would spew water, ammonia, or other volatile substances that freeze instantly in the vacuum of space, creating those brilliant, icy deposits. Alternatively, a recent impact could have excavated the surface, blasting away the dark topsoil to reveal the pristine ice hidden beneath. Yet the localized nature of these patches is another clue. Why are they confined to specific areas instead of being spread evenly? This suggests that the internal engine driving this activity is not global, but focused in particular hotspots, perhaps where the icy crust is thinnest or where internal heat from radioactive decay manages to concentrate. These bright spots are more than just surface features. They are windows into the dynamic heart of a world we once thought was frozen and dead. These gleaming bright spots contribute to a planet-wide phenomenon that is just as baffling. Orcus possesses an unexpectedly high albedo, a scientific term for how reflective its surface is. Simply put, this distant world is surprisingly shiny. In the deep freeze of the Kuiper Belt, most objects are dark and sooty, their surfaces ancient and battered by millions of years of radiation. They are like old asphalt, absorbing sunlight rather than bouncing it back. Orcus, however, gleams like a dirty snowball, reflecting a significant portion of the light that reaches it. This unusual brightness immediately creates a puzzle. How can something so far from the sun, in a region of perpetual cosmic winter, maintain such a pristine, reflective face? The natural state for these distant objects is to darken over time. Think of a car left outside for decades, its paint fading under the relentless sun. In space, the sun's radiation and a constant rain of cosmic dust act like that aging sunlight, slowly but surely painting every surface a dark charcoal gray. For Orcus to defy this universal darkening process, something must be actively cleaning its surface or delivering new, bright material. This suggests that Orcus is not a static, fossilized world. It must be geologically active. The most compelling explanation points to internal heat. Even out in the frozen darkness, radioactive elements deep within its rocky core could be decaying, providing a subtle but persistent source of warmth. This heat might be just enough to power slow-moving geological processes, perhaps causing plumes of fresh, clean water ice to erupt from below and coat the surface, effectively giving it a new, shiny layer of paint. Alternatively, the constant tug of gravity between Orcus and its moon Vanth could be flexing the dwarf planet's interior, generating friction and warmth in a process known as tidal heating. This is the same kind of energy that keeps the subsurface oceans of Jupiter's moon Europa liquid. On Orcus, that energy could be driving the resurfacing activity that keeps it so bright. This high albedo is more than just a curious observation. It is direct evidence that this distant world is alive with hidden processes, challenging our very understanding of what it means to be a cold, dead rock in the outer solar system. Those gleaming surfaces and puzzling reflections lead us directly to an even deeper thermal mystery. Scientists measuring the faint heat radiating from Orcus have detected something fundamentally wrong with its temperature. The readings they get do not match the predictions for a simple, frozen world at its immense distance from the sun. There are strange, unexplained variations in its warmth, hotspots and cold spots that should not exist on a passive ball of rock and ice. This is a thermal anomaly, a direct sign that the energy budget of this dwarf planet is out of balance. If Orcus were merely a cold, dead relic, its temperature would be uniform and predictable, dictated solely by the weak sunlight it receives. Instead, it seems to have its own internal thermostat, generating and distributing heat in ways we are only beginning to comprehend. So where is this extra warmth coming from? The prime suspect is radioactive decay deep within its core. Just like the rocks in Earth's crust, the rocky material inside Orcus likely contains elements like potassium, thorium, and uranium. As these atoms slowly and steadily break down over billions of years, they release heat. On a small world, this heat would normally escape into space long ago. But if Orcus is larger or more insulated than we think, it could be trapping that energy, creating a warm heart within its icy shell. Another powerful source could be its gravitational dance with its moon, Vanth. As the two bodies pull on each other, their gravitational forces constantly stretch and flex the interior of Orcus. This repeated kneading action, known as tidal heating, generates friction and warmth. It is the same process that keeps the underground ocean on Jupiter's moon, Europa, from freezing solid. The constant tug of war between Orcus and Vanth could be providing a steady internal power source. There is even a more speculative possibility that Orcus is still holding onto a remnant of the immense heat from its own violent birth, a fossil warmth from the colossal collisions that formed it. This would mean its interior is incredibly well insulated, a thermos bottle in the void of space. These thermal anomalies are not just a scientific curiosity. They are the most direct evidence we have that Orcus is not the static, fossilized world it appears to be from afar. It is a dynamic place with a complex internal engine that actively shapes its surface, its structure, and potentially, its capacity to host environments unlike any we have ever imagined. What other secrets is this internal heat protecting deep within its frozen core? The very warmth emanating from Orcus complicates the story written upon its surface. When astronomers point their spectrometers toward this distant world, they receive a deeply puzzling chemical message. The light reflected from Orcus tells a story of conflicting ingredients, a surface composition that should not logically exist together in one place. The data reveals the brilliant, unmistakable signature of crystalline water ice, the same kind that forms snowflakes on Earth. But mixed right in with it are the spectral fingerprints of ammonia hydrates and dark, complex organic compounds, the kind of tarry material often found on asteroids. This is the composition conundrum. It is like finding a spotless, modern kitchen right next to a primordial tar pit. These substances have vastly different histories and stabilities, and their peaceful coexistence on one small world defies easy explanation. Water ice, especially in its clean, crystalline form, is a fragile substance in the harsh environment of space. Over millions of years, bombardment by cosmic radiation should damage its crystal structure, turning it into a dull, amorphous glass. The presence of fresh, crystalline ice strongly suggests that it has been recently exposed, laid down on the surface within a relatively short cosmic time frame. This points directly to ongoing geological activity, perhaps those cryovolcanic eruptions we considered earlier, spewing fresh water that flash freezes into a bright new layer. But then we have the ammonia. Ammonia is a volatile chemical, meaning it easily turns from a solid into a gas. It acts as a powerful antifreeze. If ammonia is mixed with water deep inside Orcus, it could lower the freezing point of the mixture dramatically, allowing it to remain liquid at far colder temperatures and potentially creating a slushy mantle or even a subsurface ocean. The presence of ammonia on the surface could be the telltale sign of this internal cocktail, vented from below through cryovolcanic processes, yet this still leaves the mystery of the dark organic gunk. These complex carbon-rich molecules are the building blocks of life, but they are also notoriously dark and absorbent. How do they remain scattered across a surface that is simultaneously being scrubbed clean by erupting ice? One possibility is that they represent the ancient, original surface of Orcus, a relic crust from its formation 4.5 billion years ago. The bright ices would then be newer patches like fresh paint over an old stained wall. Alternatively, the dark material might be delivered from outside, the cosmic soot that continually settles across the Kuiper Belt, only to be covered up in some places by Orcus's own internal activity. This messy blend of materials is a frozen record of the dwarf planet's entire history. It hints at an active interior that regularly refreshes parts of the surface, while other areas remain untouched, preserving a primordial landscape. Each substance is a clue. The water ice suggests present-day activity. The ammonia points to a warmer, more complex interior. The dark organics whisper of a birth in the ancient, chemical-rich cloud that formed our solar system. Unraveling how these pieces fit together is the key to understanding not just what Orcus is made of, but the dynamic and surprising life cycle of worlds in the solar system's final frontier. This chemical puzzle leads to a profound silence in the thin, cold void surrounding Orcus itself. We find a world that, by all rights, might whisper with a faint atmosphere, yet our instruments detect only an eerie quiet. Other distant dwarf planets, like Pluto, manage to sustain a tenuous shroud of gas, created when the weak sunlight causes volatile ices on their surfaces to sublimate, turning directly from a solid into a gas. Given the presence of those bright water ice patches and ammonia hydrates, scientists expected to find at least a temporary, seasonal atmosphere around Orcus, a faint exhalation as it nears the sun. Yet so far there is nothing. This puzzling lack of a detectable atmosphere forces us to ask a difficult question. Where did all the air go? One possibility is that any atmosphere Orcus does possess is simply too thin and tenuous for our current technology to observe. It could be a ghost of a gas layer clinging so close to the surface that it is virtually invisible from Earth. Another, more dynamic theory suggests that its atmosphere is not missing but merely hiding. Perhaps it is a seasonal phenomenon that only appears for brief periods. Think of a comet, which only grows a spectacular tail when it gets close to the sun's warmth. Orcus might follow a similar cycle. When its highly elliptical orbit brings it slightly closer to the sun, surface ices could heat up just enough to sublimate and create a temporary, ultra-thin atmosphere. Then, as it swings back into the deep freeze, that entire gaseous envelope would collapse, freezing solid and falling back to the surface as a blanket of fresh frost. There is a third, more surprising explanation. The atmosphere might be locked away, trapped beneath the surface. If the bright ices we see are not exposed volatile deposits, but are instead a thick, insulating crust of relatively stable water ice, then any more volatile gases like nitrogen, methane, or carbon monoxide could be sealed in a subsurface reservoir, unable to escape. This would make Orcus less like a comet and more like a sealed thermos, keeping its most volatile content securely contained. The absence of an atmosphere is not just an empty observation. It is a critical clue about the nature and history of this dwarf planet. It tells us that Orcus is either exceptionally good at holding onto its volatile materials internally, or it has somehow lost them all over billions of years. This stark contrast with its twin, Pluto, which boasts a complex, hazy atmosphere, deepens the mystery of their mirrored orbits. If they formed from similar materials in the same region of space, why did one retain its gases while the other seemingly did not? The silence surrounding Orcus speaks volumes about the delicate and unpredictable ways that worlds manage their most precious resources in the cold, unforgiving expanse of the Kuiper Belt. This strange silence surrounding Orcus is matched only by the peculiar way it spins in the darkness. The dwarf planet's rotation period and the tilt of its axis are deeply unusual, presenting another layer of mystery to this distant world. Unlike many of its Kuiper Belt neighbors that tumble chaotically or spin with frantic speed, Orcus rotates at a measured, almost deliberate pace. Its day is not a blur but a slow, consistent turn. Even more telling is its axial tilt, the angle at which it leans relative to the plane of its orbit around the Sun. This tilt is significant, meaning Orcus does not spin upright like a top, but is instead cocked over on its side, presenting its poles and equator to the Sun in a slow, cyclical dance over its long year. This configuration is not random. Such a specific rotational state is a fossil record, a preserved memory of the most violent and formative events in this world's history. A major impact, a colossal collision with another large body in the early solar system, could have literally knocked Orcus onto its side, permanently altering its spin and tilt in a single, catastrophic moment. The gravitational relationship with its moon Vanth offers another explanation. Over billions of years, the persistent gravitational tug-of-war between the two bodies could have acted as a brake, slowing Orcus's initial frantic spin down to its current leisurely pace, while also gradually pulling its axis into its present tilted orientation. This process, known as tidal locking, is why our moon always shows the same face to Earth, but with Orcus and Vanth, the effect may be more complex, resulting in this strange, stable but tilted spin. When we compare Orcus to other large Kuiper Belt objects, its rotational properties stand out as unique. This is not the norm. It suggests that the story of its formation was not a quiet one. The specific way it spins today holds direct clues about the ancient violence that created its binary partnership with Vanth. Was it a single, shattering impact that gave birth to the moon and set the dwarf planet spinning on its side? Or was it a slower, more graceful gravitational dance that orchestrated this peculiar rotation over eons? The answer is written in the slow, tilted turn of this distant world, a silent clock pointing back to the moment of its birth. This peculiar tilt is not the only way Orcus stands apart from its companion. A deeper mystery is painted in color across the surfaces of Orcus and its moon Vanth. When astronomers measure their hues, they find a clear and puzzling divide. The dwarf planet Orcus itself reflects a relatively neutral grayish light, but Vanth, the moon orbiting so close beside it, glows with a distinctly reddish tint. This is the Vanth-Orcus color dichotomy, a stark visual mismatch in a system that should, by all rights, share a common history. How can two objects locked in such an intimate gravitational embrace for billions of years look so different from one another? It is like finding two identical twins raised in the same house, yet one has pale skin and the other a deep tan. This color difference is a direct clue that their surface stories have dramatically diverged. The leading theory points to the relentless process of space weathering. In the airless void, surfaces are constantly bombarded by solar wind and cosmic radiation. This radiation acts like a cosmic spray tan, slowly breaking down complex molecules, particularly organic compounds, and turning surfaces a darker, redder shade over millions of years. If this is the case, then Vanth's reddish color suggests it has an ancient, unaltered surface that has been baking in this radiation for eons. Orcus, with its neutral color, would then have a younger, recently resurfaced face where fresh ice or other materials have covered up those old, reddened layers. This perfectly aligns with the mystery of its bright spots and high reflectivity. Its surface is being actively renewed, wiping the cosmic tan away. Another possibility is that they were simply born different. Perhaps the giant impact that might have created Vanth dredged up material from deep within the original Orcus, material with a fundamentally different composition that was always richer in red-tinted minerals or complex organics. In this scenario, Vanth is not weathered, it is just painted with a different primordial pigment. A third fascinating idea involves external contamination. Vanth, being the smaller object, has a weaker gravitational pull. It is far easier for it to capture drifting dust and debris from the Kuiper Belt. Over time, a steady rain of reddish, carbon-rich material from passing comets or asteroid collisions could have settled on Vanth, painting it red without affecting the larger, gravity-stronger Orcus. This would mean Vanth's color is not its own but a stolen coat of cosmic dust. Each explanation tells a different story about the lives of these two worlds. Is Orcus a geologically active world constantly refreshing its appearance, while Vanth is a dormant, ancient relic? Or are we looking at two distinct primordial compositions forced together by a long-ago collision? The color difference is more than a visual curiosity. It is a fundamental disagreement between two partners that have shared the same corner of space since the beginning, forcing us to question what we really know about the shared histories of binary worlds. The vibrant color difference between Orcus and its moon is just one piece of a much larger gravitational puzzle. Astronomers tracking the precise orbital dance of Orcus and Vanth have detected faint, ghostly tugs that cannot be explained by the two bodies alone. These are gravitational perturbations, subtle wobbles and hesitations in their path that hint at the presence of unseen mass lurking in the darkness around them. Imagine trying to predict the exact swing of a pendulum, only to find it consistently nudged off course by an invisible hand. That is the kind of mystery scientists face here. These tiny deviations challenge our entire understanding of the Orcus system's weight and composition. Our current models, based on the observed sizes and orbits of Orcus and Vanth, predict a certain mass and density for the dwarf planet. But these gravitational whispers suggest our calculations are wrong, that there is more mass present than we can see. So what is creating this hidden gravitational pull? One compelling possibility is the existence of undiscovered moons, perhaps a small, dark companion, too faint for our telescopes to spot, orbits Orcus further out. Its gravity would gently pull on both Orcus and Vanth, introducing a slight wobble into their otherwise predictable dance. Another theory points to a debris ring, a thin, dusty circle of ice and rock remnants from some ancient collision encircling the dwarf planet. While individually insignificant, the combined mass of countless tiny particles could exert just enough gravitational influence to produce the observed anomalies. The most profound explanation, however, involves the environment itself. Orcus does not travel through a perfect void. It moves through the Kuiper Belt, a region teeming with countless other frozen worlds. The gravitational tugs we see might not be from something orbiting Orcus directly, but from a close, unseen Kuiper Belt object passing through its neighborhood, a dark, wandering giant whose gravity briefly distorts the local space. Each of these possibilities carries dramatic implications. A hidden moon or a ring would reveal that the Orcus system is far more complex than a simple binary partnership. It would be a miniature solar system in its own right, with a history of collisions and captures we have yet to decipher. If the perturbations come from a passing Kuiper Belt object, it forces us to confront how crowded and dynamically active this distant realm truly is, challenging our models of its long-term stability. These ghostly tugs are more than just a mathematical curiosity. They are a direct signal that our map of this distant world is incomplete, that invisible forces are at play in the darkness, subtly shaping the path of one of the solar system's most mysterious worlds. The unseen forces tugging at Orcus point toward a hidden reality deep within its frozen shell. To truly understand this world, we must journey to its very heart and confront the enigma of its internal structure. Is Orcus a neatly layered world with a dense rocky core wrapped in a thick mantle of ice? Or is it a chaotic, primordial jumble of rock and ice mixed together from its birth? This is not an abstract geological question. The answer determines whether this distant dwarf planet harbors a secret ocean and what kind of internal heat could be warming it from within. If Orcus is differentiated, meaning it has separated into distinct layers, it would possess a heavy core rich in radioactive elements. The decay of these elements would provide a steady, billion-year-long furnace, generating the warmth that could maintain a liquid water ocean trapped between the rocky core and the icy crust. This layered structure is what we suspect exists within Pluto, a world with likely a subsurface ocean, and it may be the key to geological activity on these distant bodies. But if Orcus is undifferentiated, a more homogeneous blend of rock and ice, its story changes completely. Such a structure would be a cosmic fossil, a preserved relic from the solar system's earliest days that never got hot enough to melt and separate. Its internal heat would be minimal, and the possibility of a subsurface ocean would vanish, replaced by a permanently frozen interior. The presence of its large moon, Vanth, is a crucial clue in this mystery. The most widely accepted theory for Vanth's formation is a giant impact, a colossal collision in the ancient Kuiper Belt. For such an impact to eject enough material to form a moon, the proto-Orcus would likely have needed a differentiated interior. A mixed rocky ice body might have simply absorbed the shock or shattered into pieces, rather than cleanly ejecting a disk of debris that could coalesce into a companion. Yet, the evidence is not all one-sided. Orcus's density, what we can infer of it, sits in a puzzling middle ground. It is not dense enough to be purely rocky, nor light enough to be mostly ice. This ambiguous density is the core of the enigma, perfectly consistent with either a differentiated structure or a specific, intimate mixture of rock and ice. How does this compare to its distant cousins? Pluto, larger and more massive, almost certainly has a differentiated interior and strong evidence for a subsurface ocean. Eris, even more massive than Pluto, is so dense it must have a very large rocky core. Orcus sits between them, a medium-sized world whose internal blueprint remains a locked secret. Its structure is the master key that determines its thermal history, its geological potential, and its capacity to host one of the most precious substances in the universe, liquid water. Is the heart of Orcus a warm, layered world holding a hidden sea, or is it a frozen, primordial snowball unchanged for 4.5 billion years? The silent tug of gravity and the puzzling heat from its surface suggest the former, but until we look closer, the architecture of this distant world remains one of its most profound and personal mysteries. The youthful face of Orcus is a cosmic contradiction. Here, in the solar system's most ancient and battered neighborhood, we find vast plains that are strangely smooth, their surfaces almost completely free of the crater scars that mark every other old world. It is like discovering a freshly paved road cutting through a prehistoric landscape. This lack of craters is one of the most direct and puzzling clues we have. In the Kuiper Belt, objects are constantly pelted by wandering ice and rock. A surface left untouched for billions of years should be a pockmarked testament to that relentless bombardment. The clean slate we see on parts of Orcus can mean only one thing: its face has been wiped clean in the relatively recent geological past. Something is actively erasing the evidence of impacts, a process that demands a powerful and unexpected source of energy. So what force could possibly be resurfacing this frozen world so far from the sun's warmth? The prime suspect is cryovolcanism. Instead of fiery magma, imagine a volcano that erupts with a frigid slurry of water, ammonia, and methane. This slushy mix would flow across the landscape, a slow-moving glacier of ice that fills in old craters and creates entirely new, smooth plains before freezing solid into a bright, fresh layer. This process would not only explain the youthful terrain, but also those brilliant, reflective patches we see. Another possibility is tectonic activity. The icy crust of Orcus might not be a single, solid shell. Internal heat could be causing it to stretch and crack, with new sheets of ice pushing up from below, much like the shifting tectonic plates on Earth, but occurring in slow motion over millions of years. These new icy plates would form unblemished surfaces covering the old, cratered ground beneath. A third, more subtle mechanism involves seasonal sublimation. As Orcus moves along its elliptical orbit, the faint increase in solar energy might be just enough to cause the most volatile ices on its surface, like nitrogen or methane, to turn directly from a solid into a gas. This process could subtly reshape the landscape, smoothing over small features and erasing the faintest craters over countless cycles. The true mystery is not just that this happens, but how it happens on such a small and distant body. The internal heat required to power cryovolcanism or tectonics should have leaked away into space eons ago. This forces us to reconsider the very nature of Orcus's heart. Is its core rich with long-lived radioactive elements that provide a steady, billion-year warmth? Or is the gravitational tug of war with its moon Vanth constantly flexing its interior, generating enough tidal friction to melt ice and drive these surface renewals? The youthful face of Orcus is a defiant statement, a clear sign that even in the deepest freeze, small worlds can cling to a dynamic, surprising life. Even the light bouncing off Orcus holds secrets we cannot yet decipher. When astronomers analyze its infrared signature, the unique fingerprint of its chemical makeup, they find bizarre gaps and spikes in the data. These are unexplained absorption bands, dark lines in the rainbow of reflected light where something on the surface is absorbing specific colors of infrared energy. The problem is, these bands do not match the known signatures of any common ice or mineral we have catalogued from Earth or other planets. It is like hearing a song where several notes are consistently out of tune, played by an instrument we have never seen before. This spectral anomaly suggests the surface of Orcus is coated with exotic compounds or materials in strange physical states that defy our current library of cosmic chemistry. One compelling hypothesis points to complex organic molecules, far more intricate than the simple, dark tars we find elsewhere. These could be tholins, large, complex molecules created when simple ices like methane are bombarded by radiation over millions of years. This cosmic chemistry experiment, running continuously on the surface of Orcus, could be manufacturing a unique cocktail of reddened, complex organics whose precise infrared signature we have simply never measured before. Another idea involves heavily irradiated water ice. Normal water ice has a very specific infrared fingerprint. But what if the constant barrage of cosmic rays on Orcus has damaged the crystal structure of its ice in a novel way, creating a distorted, amorphous solid that absorbs light in these strange new patterns? This would be a form of ice that does not naturally exist on Earth, forged only in the extreme environments of the deep Kuiper Belt. The most tantalizing possibility is that we are seeing the signature of an entirely unknown crystalline structure. Just as carbon can form graphite or diamond, water and ammonia ices might be able to form exotic, high-pressure crystal arrangements under the unique conditions within Orcus. Perhaps these materials are being created deep in a warm, slushy layer beneath the crust and are then brought to the surface by its geological activity, giving us a glimpse of chemistry that is literally alien to our experience. These odd spectral features are more than a scientific curiosity. They are a direct challenge to our understanding of the Kuiper Belt's chemical diversity. If common ices can be transformed into such unusual substances, then the entire outer solar system might be a vast laboratory for chemical processes we are only beginning to imagine. What other unknown compounds are hiding in the frozen dark, waiting to rewrite our textbooks on the building blocks of the solar system? This unusual tilt is not just a curiosity, it is a direct challenge to our understanding of solar system order. The vast majority of planets and asteroids orbit the Sun in a relatively flat disk, like marbles rolling on a giant plate. Orcus, however, breaks this rule with a dramatic orbital inclination, its path angled sharply away from this common plane. So what colossal force could have lifted this entire world and its moon up and out of alignment? The most likely culprit is a gravitational drama that unfolded billions of years ago during the solar system's chaotic youth. As the giant planets Jupiter, Saturn, Uranus, and Neptune migrated to their current positions, their immense gravity would have acted like cosmic slingshots, violently scattering countless icy objects. Orcus could have received a powerful gravitational kick from a close encounter with Neptune, an encounter that literally knocked its orbit sideways, forever changing its trajectory through the outer darkness. But there is another, even more speculative possibility: the influence of a hidden giant. The hypothetical planet 9, a proposed world several times the mass of Earth thought to be lurking in the extreme outer solar system, could be the invisible architect. Its immense gravitational pull, exerted over billions of years, might be shepherding the orbits of many distant objects, including Orcus, into their strange, tilted configurations. This would make Orcus not just a victim of ancient chaos, but a present-day pawn in a gravitational game played by an unseen king. This profound tilt is not without consequence. It dramatically shapes the world's climate for a world that has one. As Orcus travels along its inclined path, its poles and equator take turns facing the sun for extended periods. This creates extreme seasonal shifts far more dramatic than anything on Earth. One hemisphere might bask in continuous, though faint, sunlight for decades, while the other plunges into a deep freeze that lasts just as long. This cycle would constantly shuffle surface ices, potentially triggering periods of atmospheric venting when a frozen pole swings into the light, followed by a complete collapse of that atmosphere when it swings back into darkness. It also affects our own view of this distant world. Its high inclination means that from our vantage point on Earth, Orcus spends most of its time either far above or far below the crowded plane of the solar system, making it both harder to find and easier to study in isolation, away from the bright background stars of the Milky Way. This peculiar orbital stance is a permanent scar, a reminder of a violent past that continues to define the environment and the very visibility of one of the Kuiper Belt's most enigmatic worlds. This enduring cosmic partnership between Orcus and Vanth is a marvel of celestial engineering. Their delicate gravitational dance has persisted for perhaps 4.5 billion years, a stunning feat of stability in the solar system's most chaotic and disruptive neighborhood. How has this binary system, with its two worlds whirling so closely together, managed to survive the relentless gravitational jostling of the Kuiper Belt? The forces that could tear them apart are immense. A close pass from another large Kuiper Belt object, a wandering giant like Eris or Makemake, could easily provide enough of a gravitational nudge to disrupt their balance. Such an event could send Vanth spiraling away into the void or crashing down onto Orcus in a cataclysmic finale, yet the system remains pristine and undisturbed. This remarkable survival suggests one of two incredible stories. The first is that their bond is truly primordial, forged in the same ancient event that created them, likely a colossal impact. In this scenario, they were born together and have remained locked in their intimate embrace ever since, their initial orbit so perfectly tuned that it has withstood eons of minor perturbations. The alternative is that their union is surprisingly young, the result of a capture event that occurred long after the solar system formed. This seems far less likely, as a gravitational capture requires a fantastically precise set of conditions to slow a passing object just enough for it to be captured into a stable orbit, rather than being flung away or colliding. For a capture to result in such a seemingly stable, near-circular orbit as we see today is almost too perfect to be true. The very fact that they are still together points to a powerful stabilizing force. Their mutual gravity is the glue, but the vast, empty spaces of the Kuiper Belt itself may be their greatest protector. While the region is crowded with small worlds, the distances between them are so astronomically large that close, system-shattering encounters are extraordinarily rare events. Orcus and Vanth have spent billions of years sailing through a mostly empty sea, their dance undisturbed by the distant traffic around them. This incredible longevity forces a profound question. Is their stability a common feature of binary systems in the Kuiper Belt, or is Orcus a rare, fortunate survivor? Their continued existence is a quiet testament to either a remarkably gentle birth or a cosmic fortune that has shielded them from harm across a time span longer than human history can comprehend. This missing family of fragments is a ghost story written in the emptiness of space. When we look at other large residents of the Kuiper Belt, like Haumea, we find a trail of evidence. Haumea is surrounded by a whole family of smaller objects, all sharing similar orbits and compositions, the unmistakable shrapnel from a gargantuan impact in the distant past. This is what scientists call a collisional family, and it is a common feature among these distant worlds. Yet, when we search the space around Orcus, we find nothing of the sort. The area is strangely, suspiciously clean. For a world with a large moon that was likely born from a colossal crash, this void of associated fragments is deeply puzzling. Where are all the broken pieces? One possibility is that they are there, but we simply cannot see them. Our telescopes may not yet be powerful enough to detect the faint, dark shards that would constitute a family, especially if they have been scattered far and wide. The fragments could be too small, too dark, or too distant for our current technology to pick out from the background of countless other Kuiper Belt objects. It is like trying to spot a handful of black sand scattered across a vast black beach at midnight. Another, more dynamic theory involves the relentless pull of gravity. Perhaps a family did form from the same impact that created Vanth, but over billions of years, the gravitational influence of the giant planets, particularly Neptune, has acted like a cosmic sieve. These gentle but persistent tugs would have slowly stirred the orbital pot, dispersing the fragments, scattering them across such a wide volume of space that they no longer appear related to each other or to Orcus. Their family resemblance has been erased by time and gravity. The most intriguing explanation, however, is that the impact that formed Vanth was uniquely tidy. It might have been a slower, more glancing blow, or involved objects that were already mostly differentiated, with icy outer layers and rocky cores. Such an impact could have ejected just the right amount of material to form Vanth in a neat, close orbit, without producing a massive cloud of secondary debris. In this scenario, the missing family is not missing at all. It simply never existed in the first place because the birth of Vanth was a surgical strike, not a messy explosion. This silent void around Orcus forces us to question the very nature of violence in the early Kuiper Belt. Was it a region of chaotic, shattering impacts, or were some collisions strangely precise? The answer holds the key to understanding whether the creation of binary worlds like Orcus and Vanth was a common, messy process or a rare and delicate act of cosmic sculpture. This profound silence extends beyond the absence of an atmosphere into an even deeper quiet. From the frozen darkness where Orcus resides, our most sensitive instruments detect no unexpected whispers of heat and no crackle of radio waves. This is a comprehensive radio silence, a void of emissions that defies our expectations for a world we suspect is geologically alive. If internal heat is indeed warming its interior or driving cryovolcanism to the surface, where is the energy signature? The lack of excess thermal emission is particularly baffling. It suggests that any heat generated deep within Orcus is not efficiently radiating out into space. One compelling explanation is that this dwarf planet is incredibly well insulated. A thick, porous crust of water ice, perhaps layered with blankets of frozen methane and nitrogen snow, could act as a perfect thermos, trapping the internal warmth and preventing it from escaping as a detectable infrared glow. The heat would be there, churning below, but its signal would be muffled, its escape blocked by a frozen ceiling. The absence of radio emissions further complicates the picture. Active worlds often generate weak radio waves through interactions between their magnetic fields and the solar wind. That we hear nothing could mean Orcus lacks a global magnetic field entirely, which is plausible for a smaller, rocky ice body. Or its field may be transient, only switching on during periods of intense internal geological activity, a dormant phase we happen to be observing. There is also the possibility that any emissions are not absent but focused. Imagine a lighthouse whose beam you cannot see because it is pointed in a direction away from Earth. If Orcus's internal engine channels energy to specific hotspots like cryovolcanic vents, the resulting thermal or radio signals might be too localized and faint for our telescopes to resolve across billions of miles. We could be staring at the dark, cold back of the world while its active face is turned away. This pervasive silence forces a difficult choice. Is Orcus a truly inert and cold world, a fossil whose internal fires went out long ago? Its youthful surface features merely the last vestiges of ancient activity. Or are we looking at a dynamic, insulated world that expertly conceals its energy, a secretive planet holding its warmth close? The answer lies in the next generation of observatories. Instruments with far greater sensitivity and resolution, perhaps a powerful new space telescope stationed beyond Earth's interfering atmosphere, might finally detect the faint, telltale warmth seeping from a crack in the ice or the subtle radio hum of a slushy ocean stirring beneath the crust. Until then, the deep quiet of Orcus remains one of its most guarded and provocative secrets. The deep quiet surrounding Orcus may be an illusion, masking a world of dramatic transformation. Evidence is mounting that this distant dwarf planet might undergo seasonal changes, a slow motion cycle of brightening and darkening that defies its frigid location. The faint sunlight at such a distance is barely a warming glow, yet something seems to be shuffling surface ices and altering its reflectivity over time. How can a world so far from the sun possibly have seasons? The secret lies in volatile transport, a slow cosmic conveyor belt driven by the most delicate of forces. Picture a patch of frozen nitrogen on the surface. As Orcus moves along its elliptical orbit, the tiny fraction of solar energy it receives fluctuates. When a region tilts toward the sun, these super-volatile ices might absorb just enough energy to sublimate, turning directly from a solid into a wisp of gas. This gas then travels across the dwarf planet, carried by its almost non-existent atmosphere, until it reaches a colder area, perhaps a pole shifting into shadow. There, it freezes back onto the surface as a fresh, bright frost. This process would slowly but constantly repaint the landscape, creating seasonal albedo variations that our telescopes could detect as a subtle shift in overall brightness. But what if the engine for these changes is not the weak sun, but the world itself? Internal heat seeping up from the radioactive core or generated by tidal friction with Vanth could create localized warm spots. These hotspots might become active during certain points in the orbit, triggering cryovolcanic eruptions that spew fresh, brilliant water ice across the surface, dramatically increasing its reflectivity for a time. This would be an internal season, a cycle driven by the world's own hidden rhythms rather than external sunlight. The implications are profound. If Orcus truly has seasons, it means its environment is dynamic and complex. It possesses a climate system, however tenuous, where materials are actively cycling between the surface and a potential atmosphere or subsurface reservoir. This would place it in a rare category of active icy worlds, suggesting that even in the deepest freeze, chemical and geological processes continue to shape and reshape the landscape. The possibility of seasons on a world like Orcus forces us to expand our definition of what a dynamic planet can be, proving that activity is not solely a privilege of the warm inner solar system. The very heart of Orcus is a question of weight and void. Its density, a number scientists struggle to pin down, tells a deeply ambiguous story. The measurements we have place it in a puzzling middle ground, not dense enough to be a solid ball of rock, yet not light enough to be a simple sphere of pristine ice. This uncertainty is the core of a structural mystery. Is Orcus a compact, solid world or a fragile, porous rubble pile? If it is porous, it would be a collection of countless icy boulders and rocks, barely held together by their own gravity, with vast empty spaces making up a significant part of its volume. This would mean it is mostly untouched since its formation, a fragile fossil from the solar system's dawn. But if it is a solid, differentiated body, it implies a history of melting and geological activity, where heavier materials sank to form a dense core while lighter ices rose to the surface, leaving no room for internal caverns. The gravitational dance with its moon Vanth holds a crucial clue to this puzzle. Over billions of years, the relentless tidal pulls between the two bodies would have gently kneaded Orcus's interior. If it started as a loose rubble pile, this constant flexing could have gradually compacted it, squeezing out the voids and pushing it toward a more solid state. The energy from this process would have generated internal heat, potentially enough to melt ice and begin the process of differentiation. Think of squeezing a snowy snowball in your hands. The pressure packs the fluffy flakes into a hard, solid ball of ice. The tides from Vanth may have done the same to Orcus on a planetary scale. Yet, the density we measure remains ambiguous, perfectly balanced between these two possibilities. This could mean we are seeing a world caught in the middle of its own evolution, a rubble pile that is only partially compacted. Or perhaps the material that makes up Orcus is inherently a specific mix of rock and ice that naturally gives this exact density, a primordial recipe that requires no melting or compression. The answer locked within its density determines not just its past but its present potential. A porous interior would be cold and inert, while a solid, differentiated structure could still harbor a warm, rocky core, fueling the geological activity that paints its surface bright and keeps its story alive. Is Orcus a fragile cosmic sponge or a dense, layered world in disguise? The truth is hidden in the subtle tug of gravity between it and its moon, a silent force that may have sculpted its very soul. Even its steady glow is not what it seems. Astronomers tracking Orcus over long periods have detected faint, irregular flickers in its light, subtle changes in brightness that do not align with its slow rotation or the predictable orbit of its moon Vanth. These unexplained photometric variations are a quiet, persistent anomaly. If the rotation of Orcus and the dance of Vanth were the only factors, the world's light curve would be a metronome, a predictable rhythm of dimming and brightening. Instead, the rhythm sometimes stutters. The light we see flickers in ways that are unique and unanticipated, suggesting that the surface of Orcus is not a static canvas but a dynamic and changing one. The most straightforward explanation is extreme surface heterogeneity. This means the terrain is not just a mix of bright and dark patches, but a complex mosaic where the distribution of these materials is constantly in flux. Imagine a vast, slow-moving kaleidoscope of ice and rock. A fresh landslide on a dark, rocky slope could momentarily dim the world's overall reflectivity. Conversely, a new eruption of brilliant white ice from a cryovolcanic vent could cause a sudden, localized brightening that we detect as a small spike in its total light. These transient events would create a light signature that is irregular and unpredictable, exactly what we seem to be observing. Another fascinating possibility involves the fleeting presence of atmospheric hazes. While we have not confirmed a permanent atmosphere, it is possible that temporary, thin clouds of gas and ice crystals form above particularly active regions. A plume of cryovolcanic vapor, for instance, could create a temporary, hazy patch in the void above Orcus. This haze would scatter sunlight, subtly altering the amount of light reflected back toward Earth and causing a brief, gentle dip or rise in brightness before the haze dissipates back into the surface frost. These variations are more than just a visual curiosity. They are a direct window into the real-time activity of this distant world. Monitoring these subtle flickers is one of the few ways we can remotely sense the pulse of Orcus. A sudden, brief brightening could be the signature of a cryovolcanic eruption happening at this very moment, a frozen geyser announcing itself across billions of miles. A slow, cyclical dimming might trace the slow migration of dark organic dust across its icy plains, driven by sublimation winds we cannot directly see. Each irregular flicker in the data is a piece of a puzzle, a clue that the story of Orcus is still being written, its surface an active and unpredictable stage. Deep beneath the frozen crust, a hidden sea may be stirring. The possibility that Orcus could harbor a vast, liquid water ocean is one of the most profound mysteries surrounding this distant world. The clues are not visible on the surface, but are written in the subtle language of its geology, its density, and its gravitational dance with its moon. To create and maintain liquid water so far from the sun requires a powerful, persistent internal furnace. The decay of radioactive elements like potassium and uranium deep within its rocky core could provide exactly that, a steady, billion-year warmth just sufficient to melt the base of the thick, icy shell. An even more dynamic source is the gravitational tug-of-war with Vanth. As the two bodies orbit one another, their mutual gravity constantly flexes the interior of Orcus, generating friction and heat through tidal forces. This is the same process that keeps the subsurface ocean of Jupiter's moon Europa from freezing solid. On Orcus, this tidal heating could be the engine that prevents a buried sea from turning into a permanent block of ice. But what is the evidence for such a fantastic idea? The youthful, crater-free plains we see suggest a surface that is being regularly renewed. A subsurface ocean provides the perfect explanation. If the icy crust is floating on a layer of liquid water, it could be constantly circulating, with warm plumes rising to melt the underside of the ice and refreezing in colder areas. This convection would erase impact craters and create those mysteriously smooth terrains, effectively resurfacing the world from below. The presence of ammonia detected spectrally on the surface adds another compelling piece to the puzzle. Ammonia is a potent antifreeze. Mixed with water in a subsurface reservoir, it could drastically lower the freezing point, allowing a slushy, salty ocean to remain liquid at the incredibly cold temperatures of the Kuiper Belt. This briny cocktail could then be vented to the surface through cracks or cryovolcanoes, explaining both the bright ice patches and the strange chemical signatures we cannot fully identify. The implications of a subsurface ocean stretch beyond geology into the realm of astrobiology. Where there is liquid water, chemical energy, and organic compounds, the potential for life, however simple, must be considered. This ocean would be a lightless, high-pressure environment cut off from the sun for billions of years. Yet on Earth, we find thriving ecosystems in the most extreme places, around deep-sea hydrothermal vents on the ocean floor. If similar vents exist on the seafloor of Orcus, powered by its internal heat, they could provide the energy and chemistry needed to sustain microbial life. The ocean would be a sanctuary, a protected environment shielded from the harsh radiation and vacuum of space, potentially preserving a record of chemical evolution that dates back to the very beginning of the solar system. Is Orcus a silent, frozen tomb, or is it a living world, its most vital secret hidden beneath a mask of ice? The evidence is mounting that this distant dwarf planet may be far more than a simple ball of rock and ice. It could be a keeper of one of the universe's most precious treasures, a hidden sea waiting in the dark. This cosmic loner is not an island. Orcus exists within a vast archipelago of frozen worlds, and its deepest secrets may be locked in its unresolved connections to distant cousins like Pluto, Eris, and Haumea. Are these scattered bodies a family with a shared history, or is each one a solitary rebel with its own unique story? The evidence is a tapestry of tantalizing similarities and stark contradictions. With Pluto, Orcus shares that eerie orbital resonance, a gravitational duet that suggests they were once part of a much larger population whose interactions choreographed their paths. Their similar sizes and the presence of large moons in both systems hint at a common formation process, perhaps a series of giant impacts that shaped the early Kuiper Belt. Yet their surfaces tell different tales. Pluto is a world of stunning complexity with nitrogen glaciers, towering mountains of water ice, and a hazy, dynamic atmosphere. Orcus, by contrast, appears more subdued, its activity focused in brilliant but isolated patches, its atmosphere a ghost or entirely absent. Why did one twin become so vibrant while the other seems more reserved? Then we have Eris, the dwarf planet that is more massive than Pluto. Eris is incredibly dense, suggesting a composition dominated by rock, a stark contrast to the lower density and potentially icier nature of Orcus. This fundamental difference in their very substance implies they formed in different parts of the primordial disk, with Eris accreting more rocky material from a region closer to the infant sun, while Orcus built itself from the lighter, icier debris farther out. And what of Haumea, the fast-spinning, football-shaped world with its own collisional family? Haumea's story is one of a catastrophic, shattering impact, a violent event that left behind a trail of debris and a wildly spinning parent body. Orcus shows no such family, and its rotation is slow and steady. This suggests that while Haumea suffered a devastating blow, the impact that created Orcus' moon Vanth may have been a gentler, more precise event, or that any resulting fragments were efficiently swept away by gravitational forces over time. So where does this leave Orcus? It is neither a perfect mirror of Pluto nor a clear sibling to Eris or Haumea. It occupies a strange middle ground, a unique blend of characteristics that makes it a critical puzzle piece. Perhaps Orcus is a missing link, a preserved example of a class of objects that were common in the early solar system, but have since been mostly destroyed or ejected. Its story might be the key to understanding the Great Divergence, the moment when the fates of these distant worlds split, sending them down radically different evolutionary paths. Is it an outlier, or is it the one that holds the standard for what a typical mid-sized Kuiper Belt object truly is? The gravitational anomalies we have traced around Orcus might not be coming from anything we can see or even comprehend with our current understanding of the universe. As we piece together its orbital wobbles and thermal puzzles, a profound possibility emerges, one that takes us to the very edge of known physics. Could the subtle, ghostly tugs on this distant world be a signature of something far more exotic than a hidden moon, something like dark matter? This invisible, mysterious substance is thought to make up most of the mass in the universe, yet it refuses to interact with light. We only infer its presence from the way it gravitationally twists the orbits of stars within galaxies. While dark matter is believed to be spread in a vast, diffuse halo throughout our galaxy, some theories suggest it could also clump into dense streams or even accumulate around massive bodies like our Sun. If a localized knot of dark matter happened to be drifting through the Orcus system, its immense but invisible gravity could easily account for those unexplained perturbations, gently pulling the dwarf planet and its moon off their predicted paths without leaving a single visible trace. Another radical idea challenges the force of gravity itself. The theory of modified Newtonian dynamics, or MUND, proposes that our understanding of gravity is incomplete, especially in the extremely weak gravitational fields found in the outer solar system. Perhaps the strange motions of Orcus are not caused by unseen mass at all, but are instead a natural consequence of gravity behaving differently when it is this faint. In this view, the anomalies are not puzzles to be solved, but expected outcomes that reveal a deeper law of physics, one that only becomes apparent in the profound stillness of the Kuiper Belt. These are thrilling, mind-bending concepts, but scientists approach them with immense caution. The golden rule of astronomy is to exhaust all conventional explanations first. Before we invoke dark matter or rewrite the laws of physics, we must be absolutely certain that we have not missed a simpler answer, like a small, undiscovered moonlet, a faint ring of dust, or even a subtle error in our measurements across such a vast distance. The true power of Orcus lies in its ability to force these questions into the open. its lingering mysteries make it a perfect natural laboratory, a distant outpost where our fundamental theories can be stress-tested against reality. If every conventional solution eventually falls short, then this small, icy world may become our first reliable signpost pointing toward a much larger and stranger cosmic reality, one hidden in plain sight just beyond the orbit of Neptune. The timing of our discoveries about Orcus is itself a strange and recurring coincidence. Certain critical observations have occurred during rare, fleeting moments when the distant world was perfectly positioned for study, as if it were revealing its secrets on a schedule of its own. These apparitions, when Orcus aligns most favorably with Earth, have consistently coincided with leaps in our technological capability, creating bursts of understanding that feel almost preordained. For instance, the detection of its moon Vanth occurred not long after the launch of the Hubble Space Telescope, an instrument that finally had the power to resolve the close pair. Had that orbital alignment happened a decade earlier, Vanth would have remained a hidden blur, and we would still see Orcus as a solitary wanderer. This pattern repeats with the study of its surface composition. The subtle spectral signatures that hinted at water ice and ammonia were captured during another brief window of ideal observation, just as new, more sensitive spectrometers were being deployed on the world's most powerful ground-based telescopes. It is a persistent synergy of cosmic geometry and human ingenuity, where the door to understanding cracks open only when both the universe and our tools are ready. This raises a profound question about observational bias. Is Orcus truly as we see it, or does our portrait of it depend entirely on these chance alignments? We have only ever seen it under specific lighting conditions and from particular angles. Its bright spots and dark planes might look completely different from another vantage point, and the absence of an atmosphere could simply be a limitation of our current snapshot in time. The future holds even greater promise. Astronomers are already calculating the next series of optimal alignments, events where Orcus will pass in front of a distant star. These stellar occultations are like cosmic ultrasounds, allowing scientists to measure its precise shape and size, and to probe for the faintest wisps of an atmosphere by watching how the starlight winks out. Each of these chance encounters in the void peels back another layer, reminding us that our knowledge of this distant world is not a continuous stream, but a story told in tantalizing, perfectly timed whispers. Yet the greatest chapter in the story of Orcus remains unwritten, waiting for a visitor from Earth. Proposed missions now on the drawing boards could transform these 25 mysteries into a single, coherent history, sending a spacecraft to finally meet this distant world face to face. One of the most promising possibilities is an extended mission for NASA, A New Horizons, the very same probe that gave us our first breathtaking look at Pluto. After its flyby of the Kuiper Belt object Arrokoth, the spacecraft still has fuel and power, and its trajectory could potentially be adjusted for a distant encounter with Orcus. While it would not be the close-up view we had of Pluto, even a distant pass would be revolutionary, providing images far sharper than any telescope can manage. We would finally see the bright spots and dark planes not as blurry pixels, but as distinct geological features, mapping their shapes and relationships in stunning detail. A dedicated orbiter, however, is the true key to unlocking every secret. Imagine a probe designed specifically for Orcus, slowing down to enter orbit around the dwarf planet and its moon Vanth. Such a mission would carry a suite of powerful instruments. High-resolution cameras would map the entire surface, tracing the outlines of potential cryovolcanoes and searching for tectonic cracks. An infrared spectrometer would scan every inch of terrain, identifying the exact chemical composition of those puzzling bright patches, and finally deciphering the strange spectral bands that currently defy explanation. A radio science experiment would use the spacecraft's precise signal to measure the gravitational tug of both Orcus and Vanth with exquisite accuracy. By tracking the subtle wobbles in the probe's orbit, scientists could map the interior structure of both bodies, determining once and for all if Orcus is a differentiated world with a rocky core and a hidden ocean, or a primordial rubble pile. This single measurement would answer the core enigma of its density and internal heat. The binary dynamics of the system would be laid bare. We would learn the precise mass, density, and composition of Vanth, solving the mystery of its reddish color and revealing whether it was born from a cataclysmic impact or gently captured. Laser altimeters would create topographic maps, revealing the true depth of its craters and the height of its potential ice mountains. Close-up observations could even hunt for the faintest traces of a seasonal atmosphere, sniffing for atoms and molecules venting from the surface. Each orbit would peel back another layer, turning abstract theories into concrete knowledge. We would witness firsthand if the surface changes with seasons, and perhaps even catch a cryovolcanic eruption in the act, watching as a plume of water ice and ammonia crystals erupts into the black sky. The journey to Orcus would be long, taking well over a decade, but the payoff would be a complete transformation. This distant point of light would become a world, a place with a known geography, a clarified history, and an understood place in the solar system's family. The 25 unexplained mysteries of Orcus would not simply be solved. They would be woven together into the epic story of a small, active, and astonishing world at the edge of the known. Our journey through the 25 unexplained mysteries of Orcus reveals a world that is far more than a frozen relic. It stands as a profound challenge to our understanding of the outer solar system, a dynamic place where gravitational dances, hidden oceans, and resurfaced plains defy simple explanation. From its synchronized orbit with Pluto to the profound possibility of a warm, liquid sea locked beneath its icy shell, Orcus consistently invites us to question our most basic assumptions about what it means to be a world. Each puzzle we have explored, from the ghostly tugs of unseen mass to the cryptic chemical messages on its surface, is a piece of a grander cosmic story waiting to be read. We want to hear which of these 25 mysteries captured your imagination the most. Was it the puzzling color dichotomy with its moon Vanth, or the silent, guarded secret of a potential subsurface ocean? Share your thoughts in the comments below, and if you enjoyed this deep dive into the wonders at the edge of our solar system, be sure to subscribe for more journeys into the unknown.